Hello everyone, for today's lesson, we'll be discussing about the limits of algebraic functions, and we'll also discussing how to evaluate the limits of algebraic functions. So there are three functions. First is getting the limit of a polynomial functions, and then we have the limit of a rational functions, and lastly we have limit of a root of a functions. So we'll be discussing how are we going to evaluate the limit of these three functions, what are the techniques that we can use in order to evaluate them, and what are the things that we have to remember when we are evaluating these kinds of functions. So let's start with limit of a polynomial functions. So let's see the element of any real numbers. If p of x is a polynomial function, then we can say that the limit of p of x as x approaches c is equal to p of c. By definitions, because as what we know, this limit refers to the value that the function approaches as x approaches c, whereas p of c means we're getting the value of the functions at this particular value, but of course, there are cases wherein we can apply the direct substitutions, meaning these two values now will be the same. One of that cases is for polynomial functions. As long as p of x or the given function is polynomial, then we can say that p of c is the same as the limit. So we can just do the direct substitutions. So let's have an example. Let's say we have to evaluate the limit of x squared plus x minus 5 as x approaches 1. As you notice that the given function is a polynomial function, therefore we can just simply do the direct substitutions. So we got the limit of x squared plus x minus 5 as x approaches 1. This will be 1 squared plus 1 minus 5. So we can simplify all of this. So we got 1 plus 1 is 2, and then 2 minus 5, we got minus 3 or a negative 3. So this is the limit of these functions. So that means as the value of x approaches 1, the value of function or the function approaches is a negative 3. Again, we can only do direct substitution if the given function is a polynomial. Again, we can only do the direct substitutions if the given function is a polynomial. Next is let's have limit of a rational functions. So let's say r of x is a rational function and c is element of the domain of R. And then we can say limit of r of x as x approaches c is just the same as r of c. This will only happen if c is element of the domain of our rational function. So if in case that c is the element, we're able to make sure this is an element of the domain, then we can do again the direct substitutions. How will you check if c is part of the domain of our rational functions? One thing that you can do is by just substituting the value of c to the denominator. And if you notice that it becomes to 0, that means c is not part of the domain, because it will make your denominator becomes to 0, and that means the function itself becomes undefined. So that's the time wherein we can say that c is not part of the domain, so we cannot do the direct substitution with that. But if in case after we substitute and the denominator is not equal to 0, then we can proceed with that direct substitution, because that means c is part of the domain. Let's have an example. Let's say we have to evaluate the limit of 3x plus 2 over 5x minus 1. So again, one thing that we have to do first is to check if the value of c given here is part of the domain of the given functions. So in checking, all you have to do is just substitute c to the denominator, because c is 2 and then we got the denominator is 5 times 2 minus 1 is equal to 9. So that means 9 is not equal to 0. because 2 is part of the domain, so we can do the direct substitutions. And then we can substitute 2 to the whole rational function itself. So let's do it. The limit of 3x plus 2 over 5x minus 1 as x approaches 2 is equal to 3 times 2 plus 2 over 5 times 2 minus 2. So we can simplify all of this, and then we got 3 times 2 plus 2 is 8, and 5 times 2 minus 1 is 9. So we got the result is 8 over 9. So therefore, the limit of the function 3x plus 2 over 5x minus 1 as x approaches 2 is equal to 8 over 9. So that's the conclusion. Next is let's have limit of a root of a function. Let n be element of natural numbers, and limit of f of x as x approaches c is equal to L. And then we can say the limit of n root of f of x as x approaches c is equal to n root of L. So here, the only thing that we have to consider is that you can get the f of x, the function, inside the radical symbol, and then you get the limit of that, and after you got the limit, then you just here to get the n root of that limit. Now the rules in radicals of course will be applied or should be applied in this case, which are n is odd. If n is odd, the radicand or our limit can be positive or negative. We're talking about radicand. So this one right here, it can be positive or negative as long as the index is odd. However, if the index is even or our n here is even, L should be greater than 0, because of course if L is negative and the index is even, we cannot get the n root of that. Or the n is even and f of x approaches L is equal to 0 through positive values. So if L is also 0, then we can still get the n root of that. So these are just the things that we have to consider. Let's have an example. So let's say we have to evaluate the limit of the square root of 7x plus 1 as x approaches 5. So what we can do is, we can get first the limit of the function inside the radical sign. So since it's 7x plus 1, that means it's a polynomial. So we can just substitute 5 to the whole function itself. And then we got the limit of the square root of 7x plus 1 as x approaches 5 is equal to the square root of 7 times 5 plus 1. And then the square root of 7 times 5 plus 1 is equal to the square root of 36. And then the square root of 36 is 6. So we got the result is 6. So therefore, the limit of the given functions, the square root of 7x plus 1 as x approaches 5 is equal to 6. So that's the conclusion. Next, let's try another example. Let's say we have to evaluate the limits of x cubed plus 2x squared minus 3x minus 8 as x approaches 3. So what we can do is, we notice that the limit given function to us, it's a polynomial. So that means we can just substitute 3 to the whole function itself. So we got the limit of x cubed plus 2x squared minus 3x minus 8 as x approaches 3 is equal to 3 cubed plus 2 times 3 squared minus 3 times 3 minus 8 is equal to 27 plus 18 minus 9 minus 8 is equal to 28. So we get the result is 28. So therefore, the limit of the given function, the x cubed plus 2x squared minus 3x minus 8 as x approaches 3 is equal to 28. So the conclusion is 28. So that's it for our lesson for today. Our lesson about the limit of algebraic function is done. So I'll see you guys in the next video. Thank you very much.